Hello and welcome. I'm Bill Wake. We're here working on a basic interpreter, and we've made a lot of progress. We finished expressions, decided to start tackling some more control structures, and we picked the hardest part, I think, of the whole language, at least kind of from a semantic point of view. It's the for loop. And we're to the point where we need to find the corresponding next statement. So I thought I'd go back a little bit and look at the semantics of this thing. So you write for x equals start to end, and you can optionally say step, and a step size, it defaults to 1. And you put a body, and then you put a next x. And, the semantics are it starts at start, x starts at start, goes through the loop with start, goes through the loop with start plus 1, and so on until it equals end. It goes through the loop with that, and then exits. If it exceeds it, it breaks out. Now, there's a couple semantic kind of things. Let's see, I'll have to go out of here. This is from the original basic description, like October 64, I guess. So you have a for loop, and you can have arbitrarily complex expressions, all right? And it goes through the body of the loop if the variable has a value less than or equal to the final value, okay, or greater than or equal if it's a negative, okay? And if you don't show up in range, you don't go through the loop at all, okay? And when you leave the loop, this is a little bit of a twist. The program has this goes to the statement following the next, but then the variable that the for loop had, it has the last value it had during the loop. So my sort of naive, well, lots of other languages don't put it that way, I guess. Many other languages, the value, if it is defined at all outside the loop, it has the value that exceeded the loop size. Okay, and so this is a little different. The case here, okay, 8 to 3 step minus 1. Okay, you get 8 7 6 5 4 3. Okay, and the value 3 on leaving the loop. And then this one, minus 3 to 12, you can start negative. That's no problem. 11, J has the value 11 when it leaves the loop, because if it adds 2, 13, then that exceeds it, so it doesn't want to do it. This is the one I thought was interesting. For z equals 2 to minus 2, the body will not be performed, okay, which makes sense because 2 is already greater than or equal to minus 2. Instead, it proceeds to the next statement. The value of z will be 1, okay, which I was totally shocked by, just unintuitive, which is the initial value 2 minus the step size 1. So what that tells us is it's actually starting the loop, before it goes into the loop, it's starting out with the value, initial value minus step size. And that was totally unexpected to me. So let's look at it from the semantics point of view. Okay, so if I try and translate the for statement on the left, okay, I'm going to write for x equals start minus step. Okay, so that's that unusual step there. I normally expect that the x would have equaled start to start with. Excuse me. Then we're going to manage a stack. We're going to push the value, the name x, the ending value, because that has to be computed once. We don't compute it every time through the loop. So we have to compute that, and then the step and the next line number. Excuse me. And the next line number is the line number for the body. So we push those on the stack, and then the next statement's going to deal with them. All right. And then lastly, we have to find the next statement that uses x as its variable. All right, and where that is located, that's a separate thing we'll go into. But at any rate, it needs to find the next statement and say go there and start the loop there. And so when it hits the first time or the nth time, it's going to pop those variables off the stack. Pop the variable, the end, the step, the body line number, then do the increment if x plus step less than or equal to end, and we're only worrying about the positive case here. Then x equals x plus step, and go back up to the body and execute the loop with that value. So it's a little funny. Like you can see x equals start minus step, and then we look at x plus step, which is start, okay? We maybe have some, range issues on the edges of things, but But this way, since we're not incrementing until we know we're going into the loop, then we know that the last time through we'll have that value that we're supposed to have. Okay, now if we are greater than end, then we need to stop the loop. So we're going to pop the for stack and just fall through to the line after the next statement. All right. Now I'm going to do this a little more explicitly. Same thing. I mean, it's the same loop. I renamed E1, E2, E3, but in kind of the terms of our interpreter, we're gonna do an assign x to equal E1, evaluate the limit, evaluate the step. Okay, those have to be evaluated before the loop body. Then we're going to assign x equals x minus the step size. Okay, and maybe we could have done that before. We probably could do that in one line if we wanted to. Then we're going to calculate the body line number, which is the next line number after the for. Push that on the for stack, find the corresponding next, and then go to it. And then as before, I've just been more explicit that we're evaluating x. That should be plus. Okay, let's fix that. Oh, up to var x, up to is plus. Okay. If adding x plus stat less than the limit, less or equal to the limit, then we're going to make the assignment x equals op to plus var x. Yeah, I've written that wrong, but hopefully you have the idea. And then go back to the body line number. Okay. And in this case, assign, evaluate next line number, evaluate, assign, go to. Those are all existing interpreter routines. So we're translating this moderately complicated statement into simpler routines, into simpler code that we already understand. So I'm turning it into basically something that's like ifs and for loops. Okay. And that we don't have yet, we don't have the for stack. Well, actually we do because we put it in last week, but we really don't have the find next. So this find next is like we have to find the corresponding next x statement. Now you're not allowed to loop. You're allowed to nest loops, but you can't have an x loop inside an x loop. So at any given point, there's only one next x that applies. But basic, it's really line oriented, and so there's no. I mean, in almost every modern-ish language, you have blocks of some sort, and like in even Modula 2, or they would have while and end while, or in C-based languages, you tend to have braces, holding the body. That's a very syntactic construct in most languages, but in BASIC, it's not. Each line kind of stands alone. And so how do we figure out which next corresponds? Well, I don't have access to the original BASIC to test my theory, but I think it's going to say you need to match the nearest next x below you, because we have to figure out the next line. Sorry, the body. No. The corresponding next, right? We got to find that next statement so we can jump down there, and we're processing the for line, and yet somehow we have to jump down. We have to set up a jump to a line that we haven't seen yet, and so that's going to be a little complicated. The problem is I could imagine code that was like, if random number is less than half, call next x, otherwise call next x, or something like that, where somebody really kind of went out of their way to hide the next x, which next x was being used. And I could see somebody kind of rearranging go-tos to force the next x above the body. But I think we're just going to say that's just not reasonable code. And, if you go to like Visual Basic now, I'm pretty sure they're going to enforce the same kind of thing, that that it's much more of a nested syntactic structure. And, we'll enforce that same kind of thing. So my proposal for find next is we're going to go forward from the line we're on, And we're going to have to parse each line, unfortunately. This happens once at the start of a for loop, but we got to find that next statement. And we're going to go through the body and keep moving forward until we see a next X. And if we hit the bottom and we haven't seen it, then hey, there's something wrong. So it sort of doesn't allow these more dynamic or more artificial ones. It really says you got to have a for and you got to have a next. Now we will take into account the nesting. So, we're not going to look for the next statement. We're going to look for the next X, where X is the variable running this. Now you might be able to, I just don't know. You might be able to be more sophisticated. Like this thing of scanning forward, right? It's going to be relatively expensive for a for loop to find its next. It's a price we're paying in the interpreter. We could probably find a way to cache stuff. And, if this is line 100 on the for statement, we can probably, design something that found it once. Okay. If the thing doesn't exist, then there's a problem. But I don't think we're going to worry about that too much. Now, the other thing I'll say is there's an interpreter approach and there's a compiler approach. I think the original BASIC may have been more of a compiler. And in that case, you might switch around like where the assignments are and the ifs and all that stuff. If you're a one-pass compiler, it'd sure be nice to generate E1, E2, and E3 all up there in that for section. Okay. And then you would still have to find the next X and do something there, but they would already be calculated there or referenced there. I don't know. It would simplify the next statement. If you're a more sophisticated optimizing compiler, you might prefer something more like this that's here, because the evaluate, notice in the next, the if evaluate op to plus and so on. That way we're doing a conditional jump back up to the top rather than an unconditional jump at the bottom that always goes to the top, like you might implement a while loop. That is slightly more efficient in most cases, in most computers, or at least I think so. It's so hard to know nowadays, but it's one fewer jump, so it's got to help, right? And fewer instructions probably means more likely to be in the cache and stuff like that. So, it's a reasonable optimization as well. All right. So I think we've got a pretty concrete semantics here that will work. What we did last week was most of this. I think I maybe flipped the condition backwards or something. We'll have to see that, but but we're going to basically follow this, but we have to do get the corresponding next. That's our real focus for this morning, or my morning anyway. And I think, the way we do it now is just not gonna cut it. All right, let's go to this. Now, I had massive trouble with Xcode this morning. It took several retries to reboot it, and rebooting the computer a couple times, and it seems back to normal. Hey, Rick, good to see you. It seems normal now, so I hope. But I went as far as downloading app code and installing that, and tried this one more time, and it worked. So hopefully it'll keep going for us. All right, so our goal: find the textually next with the same variable, and let's find the interpreter. And our for, we have do for, do next. Let's go down to do next. Okay. This logic is what I noticed. I flipped around in the description. If counter is greater than limit, then pop that last time. Find the program after this line and go to it. Well, that can be simplified because by default we go to the line after a given line. So I think we're going to reverse this. It would sure be nice if refactored. It's not even an option. Okay. So reversing this says change greater than to the opposite, which is less than or equal. And I'm going to swap the bodies. and run the tests. Okay, so while that's going, so if the counter is less than or equal to the limit, then that's good. We should go repeat the loop and counter variable. Oh, have we done this the same? I don't know if that's quite right. Because we don't just want to evaluate the variable. We need to do, let me get to this one. X plus step greater than or equal to end, or less than or equal to end. Okay. That looks wrong to me. Okay. However, our test passed, so let's take that. I guess the thing is we have only tested so far a loop that doesn't actually execute. Okay. So this is refactor swap if branches. Okay, and then this thing, well, let's see our test. How far can we justify? Oh, we do a print afterwards. So, okay. 4 that starts out of range doesn't execute, but does adjust the variable. Okay. And we expect that to print. So if it's out of range, it should just fall through. So let's see if we do that. Line number equals program after line number. That's the current line number. We don't need that. And the go to and line number shouldn't matter. Okay, so let's, again, we'll run some tests. I don't think that part is wrong. I think it just simplifies it. Okay, so commit this. Okay. Okay. Now let's make a test. Let me prove to myself that this is wrong, because I believe this should be counter value plus step. At least that's what we checked. That's what I said to check. Okay. Because start minus step, we don't want to start at start minus step, and that's in effect what we've done. Let's see if that's true. Maybe we did it up in the 4. Okay. We do the assign. We evaluate the limit and the step size. Assign x equals x minus 2, or minus step size. And get the line after, append that stuff. Okay, yeah, I believe we have not. Okay, so now, the other thing I was going to point out in here, where's that? Find next. Okay, find next with variable. This implementation is really primitive, right? It just says, oh, we assume that's line 30. Okay, and you and I know that most programs aren't going to have line 30 with the next statement, but our tests can for now. Now this one for x. Next must match corresponding 4. How did we get that error?
interpreter. Oh, the next itself checks that. Okay. Let me add a to-do. And editing the to-do was what blew up this morning. Crazy. All right. I find the next text. Let's make sure next statement tests x plus step. Okay. Not just x. So I'm thinking there's probably a test that's like x for x equals 2 to 2 or something like that, or 2 to 1 maybe. Would that do it? I don't know. We'll find one because I'm sure it's wrong. All right. Put this over here. Okay. But for now, I want to improve this this thing that finds the next statement. All right. And in effect, we're kind of, I was going to say it's refactoring, but it's not really refactoring. It's kind of, I think of it as refactoring. I think of it as semi-refactoring because we're taking the shadow of the test is the way I look at it, that the test put a certain, require certain outputs, and they don't define everything about the shape underneath it. It's like a light projecting. Okay. And, you get a shadow of a certain shape. You can have lots of physical shapes that generate the same shadow, but they're not the same physical shape. And I think that's what we're doing to our code. We've got a shadow that, produces certain test results, and the shape we have inside can change. Sometimes refactoring, pure no behavior change kind of things. Other times we can make changes that change behavior that's not completely tested by the test, because you basically you cannot in any realistic program test all the combinations. Okay, because the simple case is x plus x equal or some value equals x plus y, and get the right value for it. Check it for 1 and 1 and 1, 1 and 2, 1 and 3, and so on. Well, you got 64-bit integers, positive and negative. So testing all those cases is a huge number of possibilities. And yet there's also the chance that just because you tested x equals 1 plus 1 worked the first time, like how do you know it's going to work the next time, right? Maybe there's some weird state that if you subtracted, a negative number before you did a positive number, that a little bit gets set somewhere and screws it up, like happened to Intel, 20 some years ago. Their floating point arithmetic thing just kept extra state, and certain operations would fail unexpectedly and stuff. The simplest statement, x plus y, and you can't trust it. Okay. You basically make a bet that it's mostly going to work. And that's okay. It's all a reliability game. There's cosmic rays or whatever that could change things too. But an absolutely complete test is impossible. So, you've got some range in there. You can do simple things and not take too much risk. And if you make big complicated changes, you are taking risk. Okay. So what would pin down? We want to pin down the finding of the statement, the next statement. All right. And so I'm going to do this. If I had said 35, well, that's still legit. It's all in order and all that, but this test will fail, I believe. Okay, good. Line number is required. Okay, I'm not necessarily knowing why I have that particular error, but I suspected what it is, oh yeah, we're saying go to 30 and it's not there. All right. However, let's find that error and do a little better. It's a chance to make a better error message. So, line number is required. Well, let's find that. A parse error. Okay, so that's if we don't find a line number when we expect it. That is definitely not the error I was expecting. That all looks good to me. Let's say found token. I'm just trying to give myself a little extra clue. If it's not an integer, if it is an integer, we get down here and we return something. If it's not an integer, okay, I'm just gonna, and that may break another test as well. We may have had an error message test. Found EOL. Wow. Okay. Have we forgotten something? Okay. Unfortunately, we'll have to stop at every line for this, but I think I want to find out what's going on. Okay. Token is integer, line 10. So we'll just step in and make sure it's going this way and continue. Token is end of line. I don't think I have any. Why would that stop here? Yeah, sure enough. Okay, let's make sure we ate everything we're supposed to here. The for loop. For do for. Okay, we skip the for, we get the variable. We eat the equals, we get the expression. If token equals, we get the 2, we get the expression. Require eats the next token, so that's okay. Step is 1 by default. If there is a step, then you do next token and that, and then return it. That all looks right to me. Okay, we're going to run it again. This one worked. I'm going to call next token an extra time. Not a valid command. I guess I'm not going to call next token. Okay, step over. Now I can see what token is. Just add end. Okay, I am totally bamboozled here. Why is this test passing with 30? Okay. If you see it, say it, because I'm not getting it. Okay, I gotta go up to line. We just call line. Okay. And we'll continue. Now token, wait a minute. Token is 30. What happened to 20? Run them again. Okay, so token is 10. Skip. Token is 30. Okay. What the heck happened? Line 20 doesn't get in there. Probably should have printed something different, but we'll just see. Token is 10. Token is 10. Token is 4. Okay. Token is 30. Somehow we got forward. 40. 9999. Okay, that's weird. It's like my for loop is not... Oh. Right. Okay. Yeah, it's because we're interpreting. All right. So in the interpreter in do for, the last thing we said was go to the next. All right. So we did find next. Okay. Let's see. So we jumped forward to the next statement, which we said was 30, and it found line 30 and did the thing. If I say 35 here, I'm not getting the error I expect. Okay. But I think that's okay. Okay, so 10. Oops. End of line token. Okay, so we've somehow got line number 0. I think that's our indication. I think that's what we do when we get a go-to that fails. Let's see how that looks. Is there a do go-to? Yes. Next line number equals new line number. Okay. So it's actually in the loop up here. Line number equals next line number or program line after. Okay. But the thing is this... Next line number is not nil, it's 30. So we go to 30. Program subline number. Okay, yeah, let's see what program does. I think we need to check a little more thoroughly, maybe. Okay, so Let's find its, oh, where's program? Subscript get program subline number. Okay, there it is. So we return an empty string if it's not found. Which maybe is okay for the program, but I think our interpreter needs to handle it. Okay, so I'm sorry. Let's go back and see how we do go to. Maybe we've left out a case there. I think we have. 10 go to 10. Okay, that's fine. Step will go to missing line. Well, that's not what we want. Well, okay, we'll try to go to missing line. Yes, that's true. Okay. Yeah, I know we don't have a good test for what happens when a line is missing. Okay. So let's do func test go to non-existent line. And this is a check program results. Let's say 10, go to 20. And we're expecting, I think we're a message that says, or maybe just line 20 not found. Line not found. Target of go to not found 20. Okay. Oh, that's really program error, right? No. All right. Let's see what we get. Okay. All right. I think, well, we certainly won't get that message, but I don't think we'll get sync useful. I think we'll get that end of line thing we just saw. Okay, let's turn this off. Okay. Line number required found UL. Yes. Okay. That's something we're asking the interpreter. I don't know the right way to do this. All right, maybe it's here. If the line is not found, the problem is, okay, it's not the go-to's job to know that. I guess that's the real issue. If the line is not found, well, I mean, it's this. We could have said it was an optional string, and then look for it here. And I think that might be the right answer. Okay, let's see our program tests. Unknown next line is 0. Zero end. I don't know what that means. Well, I think they're just wrong. I think we changed the behavior. Okay, so if you look for the line after something, the line after it, we're saying, oh, it must be the end if there's nothing there. Okay, only line after line. Line after only line is max line number. Okay. Empty program is max line number. Okay. Non-existent lines are empty. That's. Whew, do I want to? Let's try nil and change the interface and see what happens. Okay. Well, I don't think we can run. I don't think that'll build. Oh no. Okay, I guess it builds. It can't be nil because it promises to return something. All right, so let's make this string optional and run again. Okay, yeah, now it's if int new value. I don't quite get this. Set. I think I'm gonna do this. Oh, we just care about program. Okay, that one failed. Let's just do this. At least program. Ooh. Wait, compile error? I guess it contains it if it's not equal nil. Parse line, yeah. That's where things are going wrong, but let's get it parsing first. Okay, I don't think those tests were actually running. I think they were. Right. Okay, so I think, let's see, what test are we on? For outer range doesn't exist. Okay. Yeah. I don't think that's the test we care about at first here. Let's run this test. This should pass. Okay. Now we can get these others. Okay, no line number. Rem remark. Line numbers required. Okay, that's a change we made. That's okay. Okay, go to non-existent line. Okay, now that so it's not really it's really more like attempted to execute non-existent line 20. Okay, I think that is more accurate, but that's what requires the change here. Okay, so I think if the line is nil, I almost think we want to do like guard let line equal that. Else this. Okay. And then we just fall through and line will be not nil. Okay. But if it is nil, then we want to return our message. Okay. And I think it's like this, and we still haven't dealt with the output yet properly. And break. Okay, and the message is this. Line number. Okay. Yeah, that, okay. Yeah, we shouldn't need that because we did the get guard to make sure we got the value. Code after, oh. Is that, that's enough. Okay. I don't know that this is ideal. I suspect I could do better, but I think this will make this pass. No. No, a new line, okay. Okay. All right, and then back here. Okay. Now, this should have a better message. Thank you. Right. Okay. The reason it's not finding line 30 is because our our for always assumes it's looking for line 30, and we change it to 35. If we change it back to 30, our stub implementation is fine, and we get the 3 we expect. Okay, so let's leave that for there, and I think we're due for a break. Oh, actually, let's push this. So let's make sure everything runs. One failure. Oops. Nil is not equal to optional empty. Just a line number erases the entry. Yeah, if it's not there, it should be nil. And I don't even mind the assert equal for that. Okay. Because we just changed it. Default value. Okay. So handle go to non-existent line. Make program return nil if line not found. And actually the order is probably the other way around. Okay. And the reason we want to do that is better messages for our for statement. And for a go to that goes to the wrong place. Okay. A little bigger change than I wanted. Okay. I think now we're in a position to take a break and work on this next statement, finding the next statement. All right, the next statement. So 3-minute break, and I'll see you then. Hello, welcome back. All right, let's take a go at this again. So this test should now fail. Good. All right. I don't have a good. Well, let's go down there. Yeah, this find next. I mean, it's really well, let's start and then we'll see. Okay. So what we're going to do is we're going to start at the current line number, and we can always get the next line number for that. So this body line number is well, this statement is what gives us our starting point. So let's get the pieces and see what we can do with it. Okay, so if you start at program.line after line number, and then let's see what that thing does. Okay, so start index finds that. If it doesn't find the current line number, it returns max line number. If it finds something too big, it returns max line number. Okay, so we're going to look for max line number. Okay, so well, let's see. So we're going to do some sort of loop while start is less than program dot max line number, then do something. Okay, if it equals max line number, then that means we got there and we ran through the rest of the program and did not see the corresponding next X. Okay, so let's make a test for that one. I guess it's func test. Well, this is not really right. Oh, we want to have a for without next reports error. right. This test fails. If it, assuming it builds, okay, yeah. Well, it certainly fails because we don't have that message, period. Should have thrown an error. Okay, so it didn't find the error. All right, but I think if we do that here, if you didn't find it, well, yeah, we're just pinning down this case. Okay, so interpreter error dot error line number found for without next. Okay. Okay. Now we can put the rest in. This one still is not right. Okay. So now we have well, let's say line number starts out at program.lineAfter, and well, it's less than this. Okay. We want to say if, and I think we're going to do kind of like we do up here. We're going to have to parse it. This probably doesn't need to be local. Let's do it local, and then we'll see. Oops. Okay. So we're going to parse the line. Where are we getting a line? Oh, we got to go to program. Program sub line number. And we know we're getting one because it gave it to us. Okay. So we got the parse, and then I guess if well, we're gonna pull out the parse. I guess if dot, oh, I need my parse. And not the expression, but we want a dot next of variable. I guess we're just going to do a let for the moment. So let if dot next let actual variable equals parse. Okay, so if it's a next statement, then we're going to do something, and if it's not a next statement, then we're just going to advance. we'll do something with it. Okay. If, okay. All right, have I done this right? Why do I have so much trouble with this? Not if let. Okay, that's part of the problem. Ugh, okay. Yeah, that's not really what I'm looking for. All right, this is more like it. Okay. If let var equals, yeah, that's not quite what I'm after. Guard let is more. Still not quite it. Yeah, it must break with a guard let, so that's not quite right. I know we check these somewhere. It must be parser must do it. Oh, if case, that's the one. Okay, if case enter let line number equals token. That I think is what I want. Okay, I think we're there. So, all right. We start after line number. Keep going until we find max line number. We'll run the parser through the current line. If that line is a next with a variable, and the variable equals the one we're looking for, then return the line number because that's the line the next is on. Otherwise, if it's not a next, or if the variable doesn't match, we're just going to fall through to this and go dig up the next line and repeat. All right. And I believe that should pass. Okay, what do I know? Failed, found for without next. That's the line number is wrong. Doesn't execute and adjust its variable. Oh, that one might be wrong. Well, sorry, the message might be wrong. Because, yeah, okay, but this one should have passed. Okay, for that starts out of range, doesn't execute and adjusts the variable. All right. We got to 9999, found 4 without next X. All right, so let's run this break here and run this test. Okay, so line number is 10, and we'll step program after. Oh, this is a poor choice of variables, isn't it? Line number is 20. Okay, we got to change that. Line number is 20. Okay, I mean, it's keeping them straight, but no, that's not good. Let's rename this to current line. Current line. Okay, and we'll rerun that test. Okay, so the next line now, current line is now 20. If you look at our test, that should be the line after the test, right? We're looking forward. Okay. Parser, we get a parse. The parse is, oh, it's a line. That's right. Line 20 is a print. Oh. It's always a line. Oh, that brings me to another question I have. See, the line basically wraps one level of recursion around this, so everybody's got this. An alternative would be to make everybody have a line number at the beginning, and then I would cut out a thing. I would love to do that, but okay. Yeah, so we never match next because we only see lines. We don't see next statements. And I'm really thinking that might be the way to go. It's kind of a pity. Let's see. It's like I have this same. It makes a parse like, should a parse be a struct with an enum in it? Didn't we do that? Wait a minute. Was that in our Lexer? Token. Yeah, we changed token to be a struct token with the line number and column so we could report better messages. Maybe a parse is the same kind of thing. It's like a line number and a parse statement. Okay, let's make this pass and then we'll do some cleanup. Boy, will be. Okay. If case dot line let line well, the worst is we know the line is equal to the line number, so we don't care what it is. Line and let statement equal parse. I guess we want to say guard, because this is really a can't happen kind of thing. Guard case line that equals parse, else throw interpreter error dot can't happen current line, and I guess the error would be found statement at top, found statement without line. Okay. Okay. If case equals statement, then do this. All right. I'm so confident we'll just run them all. Or are we just running the one? I'm not sure. Not sure if we're doing any. I need to stop and run this. One variable. Okay, well, our test up here passed where it got to with line 35. Yeah, this one passed, meaning it found that line number and did its thing. Okay, this one, however, I don't think that is. Well, let's find out where that is. Interpreter. Oh, fair enough. Fair enough. Okay. So in effect, this is next variable. Wow. This is next must match corresponding for. Okay, so there was a preceding for, but it doesn't match. Okay, that error is actually correct, I think. But it did not get that. It got for without next. Oh, yeah. So the error now is coming up here. Okay. Let's extend this test a little. Next A. Okay. So I'm trying to catch the case where we did next Z, but we don't have a Z active. Okay. So the error we saw for without next, it doesn't. Oh no. Okay. Oh, well, this for doesn't run, so let's make one that runs. Okay. It's a little weird because the interpreter, right, it skips it. Okay, yeah. So it basically didn't ever execute this line because 1 to 2. Well, the error it had before, it wouldn't execute the Z until it got into the loop. So it was able to find it down here. And then when Z came up, the for loop stack was active, but the wrong variable was at the top. So there was improper nesting. So yeah, so I think that's okay. All right, let's run them all. I think I did. Maybe I didn't. Okay. We have the 4 statements can find their corresponding next. Okay. That's a step forward for sure. Let's see our to-do. Find the type. Yes, we've done that. Okay. A little slower. I don't know, you know, it's like an hour. But it feels long to me. June 13th. And this is all part of for next. Okay. Find the textually next to X. Okay. Make sure statements use X plus next a step. Okay. I'm also this is maybe outside of that, but get rid of line as a separate parse. And this is really dot line. Okay, and what else was I seeing there? Oh, we have some refactoring to do. Let's do that. Okay. One thing is the parse. Where that is, parser. We don't need to do this all the time. We can just do this once. I guess I don't need to do it in the constructor even. All right. And then down here, we can just use the parser we have. Okay. Make sure that passes. All right, good. So create one parser and use it in interpreter. Okay. I think this is probably the next thing. We want to make sure our next statements really work right. And where's step with negative? Let's add that separately. Oh, there it is. Okay. Make sure next statements test X plus step. Right. So the situation do next. Okay. We really want to text X. Where to go? We want to test X plus step as the counter value. And we don't. We just test X. So I want to make an error that shows that. All right. So X plus step. How can I make this go wrong? Okay, so if I did, let's try 2, 2, 2. How would that look? So X is 2. X plus step is 3. Okay, this loop should execute once, right? The starting value is less than or equal to the ending value. I think it's gonna execute twice. So X equals X minus step should be x equals 1. I think this should get 999 followed by 2. Um, 999 because x equals 2 to 2. X will equal 992. We'll execute it once. 999. Come up here. X should equal, well, x plus step is 3 to 2 should fail. And exit the loop and print the counter, which was the last value. Okay. I got a feeling this is going to fail. Yeah, good. What did we get? Yes, we executed it twice and ended up with a value of 3 because we're not subtracting that. At least I hope that's all that's going on. Okay, so evaluate typed variable. Okay, we want to evaluate op2 plus typed variable and step with globals. Okay, does that sound right? Op2 plus type variable. Yeah. And we can optimize that some. Assign type variable equals op2 plus typed variable. I guess we need all this. Yes, load. Okay, let's try that. Good. Okay. And yeah, we can fix it. All right. So the improvement I can make this isn't really counter value. It's like adjusted value or next value. Okay. So we take the variable, we evaluate variable plus 2 or plus step size. If it's less than or equal to the limit, then we assign, well, we can just assign the value now. Its type is value, so that should be okay. Okay. No reason to compute it twice. Oh. Dot number. That's okay. That's revealing my number. It would be nice to take a value there, wouldn't it? Okay. Let's make sure this passes. And I'll add a to-do. Should number take a value instead of a float? I don't know, I'm spinning off stuff faster than I'm addressing it, aren't I? Okay, but this should pass everybody. All right, and so we made, I guess an optimization. Only calculate value plus step once. And I think it's reducing duplication as well, but that's a different thing. Oh, interesting. So number is number of value, sorry. No, it's an expression here. Okay. Right. Okay, so I want to switch gears a little. So, okay, we did test this. Type of line number, type of string. That's really refactoring. It's not anything about the loop. Loops when range not exceeded, normal case, negative step values, expressions for and x must be numeric, check nested loops. I think we've done that too now. We kind of did half of it before, but now we've done both. All right. I think I want to stop the loop for a minute and go straighten out some of this stuff. Okay, maybe this should take priority, these two. The problem I see is we're using integers in several places, but a lot of the times they're really line numbers. They represent line numbers. Let's find int. Yeah. Okay. If number is a float of an int. Okay, that's formatting. Mid-dollar. These are real ints. They're positions in a string. Still that. Okay, interpreter. Error int. Okay, this error is a line number. All right, so I want to pull those out explicitly. Line number equals int. It's going to be a new type, and I'm going to use that type when I can. It's sort of the cheap way to get it, but I think we can. Yeah, there's a number of places that make that assumption. String to value, for value. This is a line number. That's string functions. Yep, those are okay. New line number is a line number. Line, we're ignoring that there. Target, I think in the parse, if expression int, yeah, that target is a line number too. So let's back this type up a little. I don't know if we care about it here. We're here. I think they're more at the parser level. This is definitely a line number. If is definitely a line number. Go to is a line number. Okay, dimension, those are integer sizes. They're not the same. Okay. No more ints. That one's that. Okay. These, don't worry about that. Okay, let's do a build. I don't know if we can. I don't know. Type alias is kind of an easy way to do it. I think it's limited in the sense that it thinks ints and line numbers are the same from the kind of assignment point of view. A lot of times we don't care. Yeah, so I think I could say line number 0 and it'll treat it as if I said int 0 and use it okay. Okay. Line number. I guess we got about this far. If let target is a line number, that's fine. We'll fix that in the function call. Let for next, okay. Evaluate didn't have any. User defined doesn't have any. Format's irrelevant. Do print is pretty much irrelevant. Target of line number. Okay. Dim doesn't matter. Index for. Okay. It's not the same index. Okay. Yeah, most of these aren't going to care. Okay, so let's find do if. Oh. I think we fixed this one, yeah. And go to. Go to there, yeah, okay. So we add type for line number, just a type alias for now. Okay, and then type event for line number. I'm not sure that's fully done, but that's just kind of refactoring. All right. String for variable names. I'm going to save that one. I don't know. Get rid of line as a separate parse. Okay, let's work on parse a little. Oh, did I maximize this? Okay. I think what I'm going to make this be is let's make it just be statement instead. I don't know if that'll mess up too much, but I think that's going to be more accurate. So I'm going to call it statement. Okay, and let's rebuild. And test. Okay, everything's good. So we renamed parse to statement. Now that was kind of the easy part. I think I want to express parse correctly. So I think parse is a public struct parse. It may need to be equatable, but we'll save that part. And then it's a line number of type line number, and it's a statement of type statement. Okay. Now nobody's using parse at this point. Well, so that should build no problem. I think though, I want the parser to return a parse. Okay. A line returns a statement. Parse returns a statement. I'm trying to think if there's an incremental way to get what I want here. It's, what can I do? Single line. Maybe I'm going to take a smaller bite. Where's? Oh, I guess it renamed the file too. I'm going to rename that file back. Well, I'll let that wait a minute. I'm going to do this instead. Type alias parse equal statement. Okay. Now that should build. Nobody's using it, but it shouldn't hurt anything. All right. Now I want to make parse. It's not going to return a statement. It's going to return a parse. Okay. Single line should return a parse. And line should return a parse. Okay, because parse is the thing with the line number. Now here, wherever it is, we return statement.line. That's not what we're going to do in the future. We're just going to return a parse with the line number and the statement parse. Okay, so I think, well, that should build. And then let's make the interpreter use that same type stuff. Okay, so I think what we want to do is a parse. Well, this type should be parse now, right? Okay. Step must take a parse. Okay, I think that's a step forward. Okay, split state parse and statement. That's not quite what we did. What did we do? We make parser and interpreter expect parse at top level. Okay, I think now I've done what I can here. I mean, I've laid some foundation, but I think I'm going to have to take this out. And then this. And now stuff's going to break build-wise. Okay, parse has no member error. Okay. Well, that one's frustrating. Line. Okay. Here, I want to return parse. With line number and a statement parse. Okay, and statement returns a statement. Okay, that much is all right. That's a problem. These parse has no member error. Oh, okay, yeah. So this, I'm going to, I've got a parse. Okay. Let statement equal parse.statement and switch on statement. Okay, is that better? This one, Dot line, let's see that thing. Dot line is a statement. I don't understand this error. Oh, sure. Sorry, where's my line again? All right. Oh, the error went away? No. Okay, this error, yes, I understand this one. I tried to get a line, but I got other stuff. Okay. What's the line number? All right, so if we get an error in the statement parse, okay, let's see what else we got. Parse has no member line. Parse, find next. Oh, we're in the interpreter. Okay. Yeah, I'm not ready to deal with the interpreter. Okay. I think I need to return... I got to figure out the line number here. Okay, let's just return something for now. Let's return... well, we're going to return a parse with line number 0 for now and the error that we got. Okay, so missing... oh, yeah. Okay, so I think that part's okay. That we probably need to return a line number. Get the line number somewhere. But interestingly, we don't really do that, do we? Okay. Let's add a note. Better error handling. Errors should return line number. I think. We may not need it, but I think I want that. Okay, so at this point, I think parser is doing the right thing, that you give it an input and it returns you a parse consisting of the line number and the result of the parse, the statement. Okay, and interpreter is still a little confused. Okay, so find next. Let's get this one first. This one first. Okay. Case line. Cannot convert statement to expected argument type parse. Step takes a parse. Okay. The fact is we don't really, this can't happen anymore. Okay. And I think we can remove it from here. Parser's not going to produce it. All right, we may need, somebody needs adjustment, but okay. Parse has no member line. Yeah, okay, so in our find next, now we're getting a parse back. Okay. And really we want to look at parse dot statement. Okay, so this dot line thing is no longer a real thing. Okay, we get the parse, just gives us the line number and statement. We don't care about the line number because we already have it. And we'll take the parse of the statement and do that. Okay, I believe this should pass. Oh, Oh, the test that assert on it. Oh, every parse test is going to be complaining. Okay, well, this is really, they're returning a parse with line number 40 and statement that. I think I can make that better, right? Parse, statement, line number. I think we can add an it. Okay, so I'm going to change these to parse. Why did the formatting get so ugly? And this is all because I deleted statement.line. Parse isn't a statement line isn't a thing anymore. This got rid of that recursive case in our interpreter too, which I did not like. So I feel like we're modeling more accurately what these things are. The parse has the line number and a statement. They're both present. Rather than go through each case and add the statement in, we just add it at the top. And, you know, some of these tests relied on it, but a lot did not. Okay, let's build. I don't really believe you. Oh, parse must conform to equatable. Okay, yeah, I kind of thought that might be true. And we can just let it synthesize that. Parse has no member error. Well, that's true. Output dot statement. Oh, this one's a little different. Result should be parse. String statement. Was a statement. Okay. This is why it would have been good to be sensitive to this earlier, so I wouldn't have had to have quite so many places to change. Yeah, really, it's a modeling thing, because you can't have a line 10 containing a line 10, right? So that says the model was not really accurate to start with. Let's find dot line, because that's the stuff that's making the trouble. I don't want to just change them all because I'm worried that there's going to be some internal ones that we just need to look at. But most of them are going to be mindless. I guess if some are and some aren't, they're not mindless, are they? And maybe this says I'd have been better off making my parsing, checking the line numbers once and then not making the parse just return statements or something, or checking the parse statement kind of thing. Still got a bunch. Oh, check parsing. Statement. This is really a parse, I guess. So that comes off. Okay. Well, we're getting closer. There's output.statement. I guess I'm going to say parse with output.LineNumber and error. Expected. I think I need another print. Well, where do you want to start? Gosh, I don't know. It's a long time since I started from scratch on that. For Swift, I've been using the Ray Wenderlich site, raywenderlich.com. Spelled a little funny. Well, it's the way it is. All in word, yeah. They've got a bunch of books that do it, and then the other one I've been using is hackingwithswift.com. Paul Hudson does that one, and so many times when I'm searching for an answer, he's got one already kind of videoed up and ready to roll. There's another one, I forget what it's called, Nerd Camp or something, that does Swift. These two for sure both have books that start back pretty close to ground zero, and they have video courses and stuff like that if you prefer that kind of mode. Yeah, I mean, I guess it's like find some material to start with and then just do as many as you can. Write as many little programs and whatnot as you can, and see what you can do. Yeah, good luck. All right, check parsing. Result equals parse to expected type statement. I don't quite know what's going on there. Value of type parse. That's result to expected type statement. I think I may have adjusted this. Let's rebuild. Assert equals requires parse conforms to equatable. I think I've said that now. Struct parse is equatable. Okay, let me do a clean. build. Yeah, okay. Extraneous labels. Yes, we got rid of the labels with the constructor. Fix. Okay. Right. And run all tests. The other thing is I use tester in development a lot. So, I mean, we got 185 tests. That's not an amazing number, but it's pretty darn good to get that that safety net underneath there. That all looks like follow-ups. All right, build. Non-zero status. Okay, I gotta clean again. Like little glitches in Xcode. All right. Get rid of line as a separate parse. Okay. And that's a refactor. It's a big one, medium one. All right. There's some cleanup here. Okay, so this goes away. Some comments. This goes away. This goes away. All right, and now it's the parser. Okay, I think we're good. Run those tests one more time. All right, and so we've moved parser, made parser return parse line number plus statement rather than embedding statement. Well, it's really line number. We had this kind of one level recursion. I mean, it sort of promised it could do multiple levels, but you never would have a line that's like 110. Inside that is line 70. Inside that is the print. Okay. Okay. That handles that to do type number, take a value, error should return line number. Okay. This is from parser. All right. Let's just take a quick break, like a minute or so, and I'm just gonna grab a drink real quick, and then we'll come back and work on the for loop again. We've made so much progress. I think the rest should be pretty simple. Yeah, we didn't type check that. Yeah, let's take that break. All right, welcome back. So let's just do a basic for loop test. For with positive step. Okay, and it's going to be a check program results. Let's go from 1 to 3, print X, and then down here, we'll print X again. Okay, that'll tell us that our X should be the equal of the last iteration should be 3, so we should see 1, 2, 3, and then 3 again. Our print isn't sophisticated enough to print on the same line yet. We'll get there. After we get through 4, maybe we'll go back to print. I don't know. There's other statements we haven't done yet. All right, now this I expect to just work at this point. I'm so optimistic, though. I've been wrong every time today. Yay. Okay. So check 4 with positive step size. Okay. Now, well, that's the normal case. The negative step values, that's going to be interesting. Let's see, this is more on the for loop. Let's push that. I see one left over on our parser we didn't fix. I just want to rename this back to parse. Okay. All right, and then the next test, loop with negative step values. Okay, this may or may not be done today. The test is very similar. I think I'm going to add does down here. Does adjust variable. For starting out of range, doesn't execute. Maybe this is but. Does adjust variable. Okay. This will be negative step. For x equals 3, 2, 1. Step minus 1. Print x, print x, print x. We should get 3, 2, 1, 1. Okay, because it will leave it at the value of the last thing through the loop. Now it's not going to work. It may be an infinite loop even. We don't handle that case. Okay, 4. All right, so we. How did that work? Right, we subtracted the step size. 3 minus minus 1 is 4, and 4 was greater than 1, so don't run. Okay, so what this is going to require it complicates the next. Okay, the step is okay, but it's this less than or equal is troublesome. Okay. And so this is if step is greater than or equal to 0 and that. Okay, so that's the case we had before. We always had step greater than or equal to 0. Cannot conform to binary integer. Step is We need as float. Okay. We got values that our interpreter manages. If the float converts step to float, if it's greater than or equal to 0, parse string. Wait, where's step? Step size. I don't know what step is. Okay, so the step size, the one we passed, we pushed on the stack. Okay. If step size is greater than or equal to 0, meaning positive steps, and the value is less than or equal to the limit, then we keep going. Okay. And this should pass all tests except this last one. Okay, one failure. Okay, but now I'm going to say, let's handle the other case. Okay, if it's that, or, does that line up? Okay. Let's take this. Okay, and I don't like that. I want that. Step size is less than 0. And this is greater than or equal to float. Okay. So, all right, let's do that. I'm going to open the front a little there. All right, and test. All right, good. So that's, yeah, let's commit that. Okay. Make for loop handle negative sizes. And I'm going to go back to our opening look here. Okay, so x equals start minus step. If we're going down, then start becomes bigger because we subtract off a -1, but then we're gonna add it in back down in the next step. But if x plus step less than or equal to end, that's what we just modified. So if it's a negative step size, then x plus step is decreasing, and so we're doing okay. All right, so I think there's nothing up top that's going to be affected by this negative step size because we still want to do start minus step. Okay, and I think, again, if we go back to the documentation, all right, they gave us this case for z equals 2 to minus 2. All right. Well, is there another negative one? No. Well, this is the one like we had. We did 3 to 1. They did 8 to 3, but we would see 3 to 1, and then we printed out the value at the end as 1. This one, 2 to minus 2, it's got a step size of 1, so I guess that's not quite the same case, but we cover that case too. All right, so I think we're done with for loops for now, for the interpreter part. Okay. I already checked that in. Good. What we haven't done, okay, we've done this. Okay, we haven't done this. So the for loop, you can't work on strings. You only work on floating point numbers. So let's find the parser for loop. Okay, so you can see we parse the initial and final and optional step, but we haven't type checked any of this stuff. So let's put something in. Let's add some stuff around that, and I think that'll take us to the end here. Okay, so let's say for we kind of have the same cases. Okay, for x equal string to 10, we should get an error that says for loop requires numeric types. Only works with numbers. Same thing here. If I do x equal 1 to even this is still a string, and we'll get the same message. And then finally, for x equals 1 to 10, step quote x quote. Okay. That. Okay, and this test should fail. I think all three will fail because they got the wrong message. Actually, no message. Okay. Yeah, so we actually just produced a for loop with a bunch of strings in them. Okay, but we need a message instead. All right, and then our parser, we have a require numeric. Oh, I thought we did. Where's our type checking? Require float type, yeah. Okay. And our for statement, okay. Variable requires a variable. This one initial requires it, to requires it, final, and step. By default, it works. We've got a numeric, so there's no problem there. Okay, and let's run those tests. Okay, probably a new line. I always forget those. Oh, numeric type is required. I think I would accept that. So we've already got a message in your for statement. If it were pointing to the string and said numeric type is required, I think that would be pretty good. Even if it's just saying line 10 numeric type is required, I think that would trigger enough. All right, so check for numeric type in for statements. Now Visual Basic, it can iterate over lots of types. Let's see, I had the document up here a minute. Was that here? Yeah. Okay, so they can have, it's very generic, right? You can have enums, you can have integers, doubles, floats, whatevers, that's fine. Enums, objects, or any type that has greater equal, less than equal, minus, and plus. Okay, so much more flexible, 40 years later, 50 years later. Okay, 60 years later, pretty close. 55, 57. Okay, let's see. So I think that closes off what I wanted to do for for loops. Okay. Links return output at top level. I'm okay with that for now. I think we want to go here. So we're almost done today. Next time, it'd be interesting to pick up on GOSUB return. We got a couple refactorings, a couple decisions. If handling should return output at top level. Let's look at that one. That might be a 2-minute one. Somewhere we have doIfThen. Right. It takes output and returns it unchanged. So why take it? And then when it calls, we're going to move this up here. So this is more like the other ones. The other statements, they have side effects and they just return the output. There's no work there. Whoops, output doesn't go in. All right. Does not return a string. Okay. So kind of a small refactoring manual, but we'll take it. Alrighty, and error reporting, Lexer handle spaces. Ooh, parser errors better. Okay. Return a line number. That's kind of the same. Yeah. So I think next time, let's get the statement stuff pulled together. I don't know how far we'll go with it, but GOSUB return gives you a simple subroutine kind of capability. The original version, the 1964 one, you can only go one level deep. So the handling of it was pretty unsophisticated. most, even the 1980s ones, 15, 20 years later, they they let you nest GOSUBs, which is reasonable. I think we'll just allow it. It just means you have to have a call stack, okay, rather than just a single call. If you only allow one level deep, you can just have a single place that you put the return address of your one level deep thing. If you're going to allow nesting, you have to have some sort of stack or remember it somewhere. OnX GoTo lets you say on X go to line 10, 20, or 30. Okay, multiple kind of a branching type thing, and multiple statements on a line if statements with more than just go-tos. All right. Errors report line and column number. Well, that seems good. Like redundant. Okay. Nux or handle spaces without normalization. Yeah, that's a good one. Okay. Test helper for parse-based tests and interpreter tests. I don't think we have a lot of those at this point. Oh, here's some. Okay. Yeah, that we'll look at that in the future. All right, but I think this is a good place to stop. So let's stop. Next time is tomorrow, Tuesday, 10 to 12:30, 10 a.m. to 12:30 p.m. Eastern Time, and 3 to 5:30 p.m. UTC. We'll continue on the interpreter. I would like to get these statement ones done because I want to bring in basically there's some old basic games that I think would be interesting to see if we can run them, at least maybe with a little editing, but see if we can run them. We got to have most of this stuff in there to do that. Maybe the print will have to be more fancy, but I want to start getting there and see what we can do. So we'll pick up there, and not quite done, but the end is mostly in sight for the interpreter side of things. I still do want to try and do this refactoring that flips it to a compiler, and that may be a couple or 3 weeks away, but I do want to give that one a go. So thanks for joining me. Rick in particular, nice to see you again, and CCEZZ, good to hear from you too. Hope you both can come back sometime, and have a good night. Bye-bye.